I'm CK. Tonight we're going to build another eurorack module. This is a VCO. I actually forget who builds this, who made this. You probably know already because it'll be in the title screen. But we'll have fun looking at it and putting it together and then hearing how it sounds. Hope you enjoy it. So I looked at my email. This is a ADDAC VCO. I purchased this one from synthcube.com. So we'll see how it goes. Let's see what's in the bag to start. Our favorite part. Eurorack cable. Let's see what's in this bubble wrap. We have the front panel, VCO, Rev 2, ADDAC Systems 2019, frequency octave select, frequency 0 to +6 octaves, and then here is 0 to +5 octaves, fine tuning, LFO, VFO, the different waveforms, sine and triangle, saw and rectangle, and then mix, FM attenuation, pulse width modulation, hard soft switch for something, sync, FM frequency modulation, and then pulse width modulation, control voltage. Looks like 1 volt per octave input. Sine, triangle, saw, pulse, I don't know what that is, I don't know whether those jacks or knobs, and then a master mix, probably potentiometer, but we'll see. So that is interesting enough to me. It's a good mix of waveforms with some other mods going into it, so that will be good. And here is 2 circuit boards with a number of surface mount components already pre-installed. And look closely at this. The board looks to be good quality. Hole plating is through hole. Silk screening is good. It's not great. It's a little blurry in some places. And down here, it's Rev 06, made in Portugal. So that's the boards and the front panel. Now we'll take a look. I got to get rid of these 2 pieces of wire. I've had these 2 pieces of wire on my workbench for like 2 weeks. I keep trying to use them in things, and I never use them in anything, and I throw them over there, and then they get back on my bench again. There's a poltergeist moving those wires. So let's see what we've got in here. I'm just going to dump it all out. Okay, it looks like, again, it's very similar to the punch, the Patching Panda punch I did the other day. All that's left for you to do in terms of the kit is putting the mechanical stuff on. Oh, that's interesting. I'll tell you what's interesting in a second. So it's all the mechanical stuff, switches, pots, power connectors, jacks. These jacks don't have any panel nuts on them. That's interesting. Some trimmer, resistors. Let's see what this range is. That's a 104. And then in this little plastic package are 2 surface mount electrolytic capacitors. So I don't know if we have to install these or not. And then here we have a foil capacitor, a big one. And a couple of transistors hanging out, just chilling in with the switches. So I need another parts bin, because we've got mechanical components mixed in with electronic components, and I don't want to get them confused or mixed up. So we'll sort them all out. We'll put all the mechanicals in here. And again, the potentiometers don't have any panel nuts either, except for this big one, which, if we take a look, oh, the big one is not a potentiometer, it's a switch. That's the Octave Switch we looked at a little bit earlier, and of course some of the pins are bent. Let me straighten them while I'm looking at it. Good knobs. They're good quality knobs with brass inserts. I like that. Bunch of pin headers. I'm going to leave the pin headers in with the with the electronic components. And 2 black screws, which will mount to the eurorack rails, I think, but I'm not actually sure. And one other, so I think I'm pretty much separated where I want to be. Let me take these screws and drop them in there. Just actually, those screws are probably for these spacers. And then 1 nylon screw. Interesting. But I will admit, this is more electronic components than I thought. So let me look at the board again. Okay, here are the 2 surface mount electrolytics. I guess they probably, I'm thinking they didn't ship them pre-installed because they stick up too high and they might have broken off. I've gotten surface mount circuit boards with electrolytic caps busted off them in the past, so that definitely can happen. Went to their website. They've got a very good build guide, lots and lots of pictures, so I can see where everything goes very well. And the thing that was probably freaking me out the most, which is this unfilled pad right here that I was concerned about because I didn't see a transistor or voltage regulator to go in there. Well, it's not ever filled in. That's unused on this board. So that's good. So with that in mind, we're going to go ahead and get started. Had to grab a piece of sandpaper to dress things up. You'll see in a minute. So, and also it took more than half a second because I had to get a bottle of wine out of the wine cellar for later if I happen to be flipping up on the side camera and you're looking at my fancy clocks. So first thing we're going to do is break the circuit boards apart, which is pretty straightforward. Now use a little sandpaper to smooth off the edge, which you don't need to do at all. I just happen to like doing it. And now the first thing we'll do is put these 2 surface mount electrolytic caps on, and I've completely forgotten where they go, so I'm refreshing my memory. Okay, a little solder pad to stabilize things. I'll get them out of the packaging, which is always the hard part because I'm not a mechanical assembly machine that's got built-in extractors for these parts to extract and place. I could make some reference to caves of steel there, but I won't because I don't want to get too obscure. So black band down to the square end, so let me get set up here, get my 0.025 solder. I've already got my little bent tip on my iron. So let me lay a little solder pad down here. That's a lot, that's too much. Take a little bit more off. That should be good. Now, my light's angled wrong. There we go. Make sure we're... I'm going to get my head in the shot. Sorry, guys. Okay, that leg's down. Now for just single sides like this, single legs, I don't use flux. I don't spread flux all over the place like I do for the chips with multi-legs, because I'm not going to foul this with anything else. There's no bridging going to be going on. More. Okay, that should be good for that one. Now we'll get the other one out. Before we get the other one out, I'm going to go ahead and put a little solder on that pad. That'll be good. Same drill, get it positioned right. So I've got plenty of leg on top of the right pad. I'm going to have to position my tweezers a little differently. Actually, I'm going to have to go completely overhand on this one. On? Nope. Nope. Didn't quite make it. There we go. That settled right in. I think that's making good contact. Well, we'll find out soon enough. I don't want to heat the capacitor up too much. Now we're going to do the cap and the two trimmer resistors on this board. That'll be the 20K and the 10K. So this is the 10K. Oh, I gotta make sure I'm putting it on right. And I double check it against the picture to make sure. Yeah. That's why pictures are so great, folks. Everybody who does lots of pictures is doing their users and their builders a huge positive service. So I'm just going to pin this leg and not care about the vertical positioning or whether it's flat against the circuit board right this second, because as you can see it's not. But then I just flip it over, heat that solder up again, and snug it down, and it's perfect. We'll do the 20K now. We'll put this cap on. Now we're going to do all the male pin headers. We can just abbreviate that to male pinheads. I think many people would agree with that assessment. This one goes here. It's nice that they pre-cut these. Not that it's hard to do that, but it's just nice when they're already cut for you. Same thing as with the variable resistors. Press on it, ow, and do what I always do. You'll see it in many videos where I'm soldering pin headers and I have my finger on on the pin header pin that I'm currently heating. And of course the pin header, being nice metal, transmits that heat directly to my finger. But I do that all the time, so. Now we're going to move over to the top board. Female half of the pin headers. Same drill as before, I'm not going to talk much about this. Now before I go any further, I'm going to do a simple placement test just to make sure I've got these will mate together well when that time comes, and it looks like all the pins are straight and connecting, so that's all good. Attach the spacers at this point. That's an interesting time to do that, but that's fine with me. So we put this through here like that, and as usual, as I say with my setup, I don't care about the torque on these that much, because these units are going either in my shop out here or in my studio, music studio inside, and they're never going to move. So I don't have to worry about jostling and things coming loose and all that. For you, you may want to pay attention to the torque a little more, or put some thread locking material like Loctite, so if you have them in a rack that you take to gigs or whatever, or clubs, so things don't loosen up and fall out. Now, interesting, on this end, for this standoff, that's where we use the nylon screw. I wonder if they had, now see, there's a jack on top of that. There's not a jack on there. It's So that's interesting that he is using a nylon one here. There must be some concern about grounding or shorting. It doesn't go flush. It's got a countersunk head, but the board, of course, is not countersunk, so that doesn't go flush. However, it's not any higher above the board than that Phillips head, so that's not a big deal. Now we'll put the rest of the trimmers on. There's a bunch of trimmers on this board. There's 1, 2, 3, I think there's 4. 1, 2, I'm looking at the diagram. And we've got this one, which is not labeled the same. It doesn't have the same silk screening on it. And then one down here. And I'm not going to talk during this either. It's just putting trimmers on. Nothing particularly interesting about that. Once you've seen one trimmer, you've seen them all. This is a 78L10. Okay, so the 78L10, I of course want it to be not interfering with the pin header, but as long as it's below, as long as it's in a horizontal plane below the trimmers, we don't have to worry about it interfering with anything. And now the other one should be a 79L05. 79L05, so we got the right parts, which is always good. So that's the two boards with all the electronic components on them. Next will be mounting all the jack switches and so on this one, but there's a little bit of prep that has to happen. He's asking for a bunch of the some of the tabs to be cut off. So okay, for these bigger trims I got my Schmidt's carbide cutters, because these carbide jaws won't take any damage. Okay, so now we're going to place all the parts. I'm not going to solder them, of course, as typical, because we want to make sure the front panel goes on well. And we do, I didn't notice that we have two different kinds of jacks. We have threaded jacks and non-threaded jacks. We've got 3 of each. Actually, we've got more. We've got 3 threaded and the rest are non-threaded. And a couple of switches. And we've got plastic pots with no panel nuts, and we've got the metal shaft ones with panel nuts. So, to make sure we get them all in the right place. Okay, the other thing is there's one 2-position switch and there's one 3-position switch, so make sure you got them in the right place. Now, one thing he did not say is to get rid of this tang here on the jacks, and obviously you have to get rid of the tang on the jacks or else this won't. So you're going to have to cut all those tangs off too. That nylon screw is really messing this one up. Again, it's the second one I've done in the last week that's had some mechanical interference from connectors or connections. I hope I can get that. First off, I hope I can get it parallel Second, I hope I can get enough solder on that. This one sitting on top of that screw is a good bit. Let me get a straight edge in here. You can see, because it's hitting that screw, it's a good 2 millimeters, 1 millimeter up. In American measure, it's 3/64 up. That's not good. That means the panel won't sit straight, won't sit parallel. I'm gonna do something. I'm gonna take this one out, and I'm gonna go in here. I'm gonna actually take these two out, and I'm gonna do surgery on that screw. I'm going to do that off camera because it may take me a little while and a little bit of fussing to find the right tool, but I can't have it, the one jack sitting 3/64 higher than all the other jacks. That's just not going to do. I just realized what's the point of doing it off camera. I did have to go get my X-Acto knife. So I'm just shaving the head of this screw so the jacks don't interfere with it. I think there's still enough remaining of the screw head above and below that we're going to have the security we need for the spacer to hold everything together. But I just want to make sure this jack sits flat. Okay, sits flat now. Now let me do the same thing for this outer one. Which won't be that bad. And again, you know, just these are not, this is not actually a nylon screw, it's a plastic screw. So the X-Acto knife cuts through it pretty quickly. If it were actually nylon, it'd be a little tougher to do. That makes me happy. Now things are going to sit flush. So that's two things that weren't in the build guide. One is having to trim off that leg on the jacks, and second is doing something about that screw. I don't know how he can redesign, how the author can redesign this, because you do need some mechanical support in there, and you've packed this edge of this end of the board really full of all these jacks. Let me double check this. Yeah, now they're all, God bless America, now they're all on the same horizontal plane. And now we put the front panel on, and then get all our switches, knobs, and jacks aligned properly. This is always the fiddliest part. This is a good solid piece of aluminum for this front panel. It's thicker than most eurorack panels I've run across. Well machined, well cast. The holes drilled for the jacks, they're a little tight. You may want to go another drill size up, or just a couple of microns more. There we go. Now we're all down and we'll get parallel. The jacks are what drive the height on this one. Every eurorack module has one or a set of components that actually drive this height. So the jacks set a height from the, oops, it's not zeroed, from the circuit board to the back of the panel of, we'll call it 12 millimeters. I can stretch it to that. So we'll want to make sure we have 12 millimeters at this end also, as we align everything to make sure it's parallel. Now we're going to put a bunch of the panel nuts on. So I'm going to do a couple of solder points. Width here, or depth here, and I'm going to spread it a little bit. And we'll go up to this end and use the Octave Switch as the height setter for this end. So to do that, I'm going to lock down one. I'm going to back that nut off a little bit, lock down one of the legs of that switch. Okay, so the Octave Switch is locked down. Now I can set the height. What are we about? Check this side. Looks pretty good. Okay, I'm going to go ahead and solder all the leads here, so we'll go into fast motion for that. Soldering's all done. Now let me double check to make sure I've got all the leads soldered, because they're scattered amidst all these other surface mount components, and you might miss some. And there's a little bit, there's some tight stuff here. This potentiometer's right up against this trimmer, and there's a little surface mount resistor right there that you don't want to dislodge or heat up. There are a couple of points along here. This joint here, these can be a little bit of a pain, but mainly just make sure that you're not getting your iron on the surface mount components that are already on the board. So now we're ready to, I'm going to put the knobs on first. Actually, first I'm going to take the panel nuts all the way down and double check my height. That's good. And that's good. It's parallel front to back, or top to bottom, however you want to look at it. The two switches are the loosest parts, so you have to push them firmly this way and tack the leads down and then solder them. Give these a quick little bit of torque without scratching the faceplate. Now let me put the knobs on. And now we'll marry the two boards. And again, we had test fitted these earlier, so pretty confident it'll go together well. Oh my. This cap is interfering with this trimmer. I mean, you can see it there, I hope. The cap is right under the trimmer. So what I'm going to do, since I had already cut this, you could probably, I mean, you'd have to move it. I mean, it's going to be if you move it inward, if you can see there, then it doesn't fit between the trimmer and the spacer shaft, and you can't go outward because that has it off the board. I'm going to actually take this off this side and put it on the other side. I think that's the only way that works. Okay, that's in, and now I can probably go ahead and mate the two surfaces without any issues this time. That was kind of funny. I'm surprised. And if there's something that I wasn't doing right, he hasn't called it out. Gosh. Okay, I'm going to complain again here in a second. This foot locking tab for the sine pot is interfering with this trimmer. So, and I don't like that. If the pin header's not going down all the way because of it, and I don't like it. So I'm going to cut that off. Let me get my carbide tips again. It's taking more time to mate these two because I keep running into mechanical interference. Okay, that's clear. This is down to the spacer is flush. This is down to the spacer is flush, flush. Now, with those spacers flush, I want to point something out. The pins are not fully in, the male pins are not fully in the female sockets. Down here, it's rather quite a bit dramatic. There's quite a bit of space, almost 1/8 of an inch. And that's, I mean, you can't do much about that because the spacer is setting the distance. Okay, so it's all together. Let me go ahead and put the power cable in its slot. Red stripe is in the right place, all good. So it's all together. A pretty good build, except for the mechanical interference problems I ran into on the screw here, this capacitor, which I had to relocate, that one leg right here that I had to trim off so this trimmer resistor wasn't interfering with it, and we still have 2 or 3 millimeters of gap on that pin header, and the other pin headers are about the same. So mechanically, I'll give it a B+. Next will be calibrating and actually trying it. Okay, time to power up and calibrate, and as you can notice, I didn't have a little amp out here and I didn't want to fire up the whole rig, so I just breadboarded a little amp out of with a LED. There are no LEDs on this, so you can't tell whether it's generating a signal except by actually hearing it. Oh, there we go. And our tuner, initial frequency you want to set to frequency at 0, octave at 0, fine tune about 12 o'clock, and now we'll do the initial frequency to the lowest frequency possible. And that's kind of oscillating. Let me see if I can get a little better positioning on this. See now, it's a little flat. Okay, so we've got that initial setup. Now let's see what the octave switch does for us. Octave is, I'll do it C2 with that octave. There's C3, C5, and we're all good. Okay, so frequency and octave seems to be fine. Now the next thing is going to be making sure the sine wave is good. So I'm going to turn off this contraption here and we'll hook up the oscilloscope. Now we've got the oscilloscope hooked up. Let me expand this a little bit. Okay, so we're a little overshot there, and now we do the sine shape trimmer, if I can remember where that is. Okay, it's right there. Now let's get the sine wave shape just perfect. It takes a lot of trimmer movement to get this sine wave set. Okay, we're close. Still a little flat on the top. And a little sharp on the bottom. Let me go past it and then come back to it. Okay, I like that pretty much. So the sine wave is trimmed up. Let me change the octave to watch what that does. Still looks good. Okay, so it's calibrated. Next stop is to put it in the test rack and give her a whirl with some MIDI commands and some control voltage changing the notes. Now we're installed in the shop eurorack test rig, and let's go through the cast of characters. It's the Befaco Midi Thing MIDI to CV, the oscillator we just built, then a punching panda VCA, and an ADSR from Befaco, and the Befaco Out, which is feeding a 15-watt amp I built about a year ago and didn't record that, so I don't have that. And I've got a little MIDI keyboard on the bottom of the rack. So we're all the way down at 0 on everything, on frequency and octave, and we're fully over to sine wave, and we've got a moderate envelope set up. So let's see. So that sounds good. That's a good solid sound wave. I'm going to bring it up an octave. And that was an octave up in CV, not in on the device. So I take it up an octave on the device. Nice clear sound. Let's go over to the triangle wave, change the potentiometer to that. Again, it sounds pretty smooth. It's a little harsher, of course, Now let's swing over to the saw and pulse wave, square wave. So we'll do saw first. Take it up an octave again. Take it down again. Now we'll go over to the pulse. Let's go ahead and make the width, pulse width wider. And the little percussive sound that we're getting there is coming from the punch module, because now we'll go all the way the other way with the pulse. Very gritty. Let me turn the volume up on that one. Now let's see, we can also, instead of coming out of mix, we'll go straight to the sine wave. Very, very sweet. Now let's go over to pulse wave all by its lonesome. And so that's it. Sounds pretty good. It's nice to be able to pull the individual waves out if you want, because then you don't have to worry about mixing or whatever. You can mix it somewhere else, or do different filtering and or a lot of other things. It's really good. I'm very happy with this module. The only challenges when building were those spots where there was interference between components when I was either trying to put them on the board or mate the boards, and I think the author of this kit could certainly take a look at that and make that a little better. But in general, well worth it and sounds really good. Hope you enjoyed it.